In the previous video, we had seen the technical difference between distance and displacement. Let us just recall the concept through a small problem. Through a rectangular plot, Sam walks from A to B to C to D and then returns to point A. At the same time, Peter starts walking from A and stops at C. Let us calculate the distance and displacement covered by Sam and Peter. Recall that distance is the total path length covered by a moving object. Sam started to walk from the point A to B to C to D and then he reached back to the point A. So, distance travelled by him will be the perimeter of this rectangular plot. That means you have to add all the side lengths, which is equal to 16 meters. Now, distance travelled by Peter again will be the total path length he had covered, which is from A to C. So, just adding those two sides, we get the answer as 8 meter. Now, let's calculate the displacement covered by Sam and Peter. Recall, displacement is the length between the initial and the final position of a moving object. Here, Sam, after starting from point A, reached back to point A itself. That means his initial and final position is point A, hence his displacement will be 0. Whereas Peter started from point A and stopped at point C. So the initial position is A, final position is C. We have to measure the length between A and C. That means we have to measure AC. In the figure, ABC forms a right angle triangle. So, in order to find the length of AC, which is the hypotenuse of the triangle, we can use Pythagoras theorem, which states that the sum of the squares of two legs of a right triangle is equal to the square of its hypotenuse. So, we get the value as 4 meter. That means Peter's displacement is 4 meter. Let us look at the motion done by Sam on a very sunny day. For the first 2 seconds, Sam moves 4 meter. Next 2 seconds, Sam covers 8 meter. The next 2 seconds, Sam covers 12 meter. And in the last 2 seconds, Sam covers 16 meter. Which means the distance covered in each 2 seconds is 4 meter. Such a motion is known as uniform motion. In a uniform motion, a body covers equal distances in equal intervals of time. Here, for every 2 seconds, Sam has covered 4 meter. So remember, in uniform motion, distance and time are both equal. In another case, Sam covers 4 meter in the first 2 seconds, 6 meter in the second 2 seconds, again 6 meters in the second 2 seconds, and in 1 second he has covered again 4 meters. Such a motion is known as non-uniform motion. Here, he covered unequal distances in equal intervals of time, or the same distance is covered in an unequal interval of time. So, in non-uniform motion, distance or time interval need not be equal. Most of the examples of motion that happens around us are actually non-uniform in nature. Let us just go through the example once again. Here, we can see that for the same time interval, there are two distances covered. That is, initially, the person covered 4 meter in the first 2 seconds, but in the next 2 slots of 2 seconds, he has covered 6 meter. Similarly, in the last 1 second, he has covered 4 meters. What is the reason behind this unequal coverage of distance or unequal time interval between covering of the same distance? You guessed it right, speed. Speed is that physical quantity that helps us to understand how fast an object is moving. Speed is defined as the distance travelled by a body in unit time. In order to calculate speed, we can use the formula speed is equal to distance by time. Here, if distance is represented by the letter S, time by t, then speed v is equal to s by t. We know that the SI unit of distance is meter and time is second. Hence, SI unit of speed is meter per second. Speed is a scalar quantity. We know that scalar quantities are quantities which can have only magnitude and does not give us any direction. Suppose I travel with a speed of 40 meter per second, then what is the distance covered in 2 seconds by me? We know that speed is equal to distance by time. So, distance is equal to speed into time. That means I have covered 80 meters of distance in 2 seconds. But this does not give me the indication of in which direction I had covered that 80 meters. That's why speed is a scalar quantity. It has only magnitude or value, but it does not specify the direction of the object. So, in order to know the speed of an object, we should know the distance covered by the object and the time taken to cover that distance. Now, the distance covered by two buses X and Y and the time taken by them is given in this problem. Let us check which of the bus moves faster. So, for bus X, the speed, which is distance by time, is 72 km per hour. Whereas, for bus Y, when we substitute the formula distance by time, the speed comes to 68 km per hour. This shows that speed of bus X is more than speed of bus Y. So, speed can be used to compare or to check the rate of motion of each object. What happens if direction is also associated with speed? Let us say that Sam traveled north at a speed of 50 meters per second for 1 minute. So, what will be the path length covered by Sam? So, again, distance is equal to V into T, which is 3000 meters towards north. Now, we know that when we specify direction, we are talking about displacement. So, here the displacement done by Sam is 3000 meters. Now, let me ask, if Sam travels 3000 meters north for 1 minute, then what will be his speed? Speed is equal to distance by time. But remember, when we have direction, it's not distance, it is displacement. So, when we use the term displacement, we have a new term here, that is velocity. That means velocity is the displacement covered by an object in unit time. In simple, velocity is speed with direction. The formula for velocity is equal to displacement by time. The alphabets used to represent velocity, displacement and time are same, that is V is equal to S by T. Since it has direction associated with it, it is a vector quantity. The SI unit of velocity is same, that is meter per second. That means if I simply say 6 kilometers per hour, I am referring to the speed of the object. But if I say 6 km per hour towards south, I am referring to the velocity. Children, speed and velocity are actually same. The only difference is velocity has direction associated with it. Velocity is speed with direction. And that is why both of them share the same SI unit, meter per second. Here are some problems for you to solve. Do solve and I'll come back with the answers in my next video. Hope you are clear with the concept speed and velocity. If you like the videos, then subscribe the channel for more videos.